Example 3 says consider the graph of the function f of x below. Use the graph to answer the following questions. So part A asks us to evaluate f of negative 2. What that means is that negative 2 represents our x value, and f of negative 2, the entire thing, represents our y value. So we want to try to figure out if our input is negative 2, what is the output? So I'm going to go along my x-axis. I found negative 2 here, and I'm drawing upwards until I hit the graph, and I've hit it there. And if I look at the y value that it represents, the y value is 4 there. So in math terminology, we would say f of negative 2 is equal to 4. So I'm going to go ahead and box that. Part B says evaluate f of positive 2. So I'm going to do the exact same thing. I'm going to look on my x-axis. I've gone ahead and I've found my positive 2 value, and I'm going to go upwards. It kind of appears that it might stop here at positive 2, but notice that there's an open circle there. So that means I'm going to skip right through that and then pause right there where I've hit the closed circle. And if I align it with the y-axis, we see that that value is positive 3. So again, in math jargon, I would say f of positive 2 is equal to 3. Part C says, for what value or values of x does f of x equal 1? So now we are given basically the output value or the y value. And if I highlight that here, notice if I were to draw a horizontal line, that it is crossing the graph at 2 locations. One of them is when x is equal to negative 1, and one of them is when x is equal to positive 1. So again, if I were to compare this to the vending machine analogy, if I pushed 1, then a snack of that 1 would pop out, and if I push negative 1 on my vending machine, that would also give me a snack of 1. So if we were to write our solution or our answer for part C, we would say the x values 1 and negative 1 give results such that f of x is equal to 1. Or another way of saying that is you could say f of 1 equals 1 and f of negative 1 is equal to 1. So either of those are sufficient. Part D says, on what intervals is f of x increasing? Now, generally this is commonly intuitive for students, but some things that we should know is that just like when we're reading in English, when we're looking at a graph on the xy plane, we read from left to right. And so a graph is increasing if, as we look at the x values from left to right, the y values are going up. So we're going to have to look at a few different intervals where our y values are increasing. So notice that our graph is going up from between 0 and 1, but also our graph is going upwards when x is greater than 2. Notice between 1 and 2, we have a horizontal line, which means that our graph is neither increasing nor decreasing there. So I want to somehow denote the highlighted intervals that I have pointed out on our graph. So I've gone ahead and I've started the first part of my sentence that represents my answer. It says, f of x is increasing when x is on the interval. And then we want to go ahead and write our solution in interval notation. And we're not going to include the endpoints since they're not technically increasing there. So the function is increasing when x is on the interval 0, 1. So basically when x is between 0 and 1. Also when x is greater than 2. So basically between 2 and infinity, since there is that arrow on the right-hand side of the graph that indicates that it's going to go forever in the right direction. But in mathematics, we need to combine these two intervals with a symbol. And this symbol is a U that looks like that. And this symbol reads union. So that is what we call the union symbol. And we use that when we are combining either two or multiple sets or intervals. So it's almost like when you think of a union as a marriage. So it's a marriage of two or multiple things. Part E asks us on what intervals is f of x decreasing. So now I'm going to highlight on my graph the function's decreasing as we read from left to right if the y values are going down. So that's happening here, basically everywhere before x is equal to 0. So let's think about how we want to write that in a sentence. So I'm going to write f of x is decreasing when x is on the interval Remember that it was everywhere before 0, so negative infinity to 0 like that. So that is our answer for part E. All right, so for part F, it asks us to find the minimum and maximum values of our function f of x. Now, notice that our graph goes on forever in the upwards directions indicated by these two arrows here that I've highlighted. So there is actually no maximum value because the graph keeps on going upward forever, but it does have a minimum value. Notice that the lowest point happens at the origin right there. So let's go ahead and think about how we want to write that out. So we would say f of x has no maximum value. And then we would say f of x has a minimum value of 0 when x equals 0. So those are our two answers for part F. Part G says, for what values of x is f of x positive, and for what values of x is f of x negative. Now, looking back at our graph, notice that the graph doesn't fall below the x-axis. That means that our function is never negative, but it is almost positive everywhere. So all of these values have a y value that is positive, except at the origin, because 0 is neither a positive nor negative number. So there are a couple of ways that you could think about the answer for this part of the question. You could write a sentence to say that f of x is positive everywhere except when x equals 0, but generally we write it again in interval notation. So let's show you how to do that. So we could say f of x is never negative, and we can say f of x is positive when x is on the interval -infinity to 0. And because I have a parenthesis here, that indicates that we are not including 0 in our interval or in our set. Union 0, comma, infinity. And so just as a reminder, this means basically all numbers, all real numbers other than 0.